Welcome to Lesson 11, Associations Between Categorical Variables. Before you begin Lesson 11, I strongly encourage you to go back to review Lessons 3 and 4. Specifically from Lesson 4, Contingency Tables, Conditional Probabilities, and Independent Events, and from Lesson 3, Risk and Odds. These are all concepts that you're going to see again in Lesson 11. These are the key topics that you're going to learn about this week. In this video, we'll walk through one example of using the 5-step hypothesis testing procedure to conduct a chi-square test of independence. We'll also look at examples of relative risk, percent change in risk, and odds ratios. The chi-square test of independence is going to use the same 5-step hypothesis testing procedure that you first learned in Lesson 8. In Step 1, we're going to identify assumptions. The first assumption is that you have two or more categorical variables. In this course, we're only going to be working with two-way chi-square tests. In other words, chi-square tests that involve exactly two categorical variables, but it is possible to conduct a chi-square test of independence with three or more categorical variables. The second assumption is that all expected values are at least 5. You'll compute this in Step 2. Now let's write our hypotheses. The null hypothesis is always going to be that there is not a relationship between the two variables in the population. The alternative hypothesis is that there is a relationship between the two variables in the population. Step 2 is to compute the chi-square test statistic. These are the formulas from your online notes. The first formula, the chi-square test statistic, you're most likely going to be computing using Minitab Express. You should, however, be able to compute expected cell values by hand. The expected cell value for any one cell is equal to the row total times the column total divided by the total sample size. There are some examples in your online notes of computing this. Step 3 is where you find the p-value. You're going to find the p-value using Minitab Express. Minitab Express is going to use the test statistic from Step 2 to construct a chi-square distribution with degrees of freedom that are equal to the number of rows minus 1 times the number of columns minus 1. Here's an example of a chi-square distribution for a 2x2 chi-square test. Recall, for a 2x2 chi-square test, the degrees of freedom would be equal to 2 minus 1 times 2 minus 1, which equals 1. So 1 degree of freedom. Again, Minitab Express is going to compute the p-value for you, so you won't actually need to construct this distribution yourself. We'll walk through one example shortly, and I will show you where the p-value is coming from on this distribution, but for the most part, you'll just use the p-value that shows up in your Minitab Express output. Step 4, as always, if p is less than or equal to alpha, reject the null hypothesis. If p is greater than alpha, fail to reject the null hypothesis. And Step 5, based on your decision in Step 4, write a conclusion in terms of the original research question. So much of this procedure should start to look very familiar to you, right? It's the same 5-step hypothesis testing procedure that you've been using since Lesson 8. The only thing that changes are the hypotheses in Step 1 and the test statistic and the distribution that you're using in Steps 2 and 3. Let's walk through one example using Minitab Express. Using data collected from a representative sample of World Campus Stat 200 students at the beginning of the fall 2016 semester, is there a relationship between dog ownership and cat ownership? Step 1, we're going to check our assumptions. We do have two categorical variables. Dog ownership was measured as yes or no, which is categorical. Similarly, cat ownership was measured as yes or no, which is categorical. So this assumption has been met. The second assumption is that all expected values are at least 5, and we're not going to compute this until Step 2. So let's write our hypotheses. The null hypothesis is that there is not a relationship between dog and cat ownership in the population. The alternative hypothesis, there is a relationship between dog and cat ownership in the population. Step 2 is to compute the chi-square test statistic. These are the formulas from your online notes, but recall we can use Minitab Express to compute this test statistic. These are the instructions for conducting a chi-square test of independence in Minitab Express for either the Mac version or the PC version. You'll see that I'm using a Mac, so I'm going to have an extra step to go through to get to the chi-square test, as opposed to if you're using a PC, you'll just go to Statistics, Cross-Tabulation, and chi-square. So let's go to Minitab Express now. Here in Minitab Express, I have my fall 2016 data set. I'm going to go to Statistics, Tables, Cross-Tabulation, and chi-square. The two variables that I'm interested in are dog and cat ownership. It really doesn't matter which variable you put into which slot here. Traditionally, the independent variable would go in the rows, the dependent variable would go in the columns. However, with this scenario, we don't have a clear independent and dependent variable. The chi-square test statistic, the p-value, all of that will be exactly the same regardless of which variable you call rows and which you call columns. Under display, we want the chi-square test for association. This is going to give you the degrees of freedom, the test statistic, and the p-value that you'll need for steps 2, 3 of the 5-step hypothesis testing procedure. Recall back in step 1, we need to check the assumption that all expected cell counts are at least 5. So we're also going to ask for the expected cell counts. We click OK. First, we have a contingency table. Each of these cells, the first or the top number that you see is the observed value, the actual count. So there were actually 183 people in our sample that do not own a dog and do not own a cat. The second value that you see is the expected count. So this is that row total times column total divided by grand total. So in other words, if dog and cat ownership were independent in the population, we would have expected 176.02 people to fall into this first cell. The second table that you get is your chi-square test output. You could ignore the bottom row. We are only going to be looking at the Pearson chi-square test statistic and p-value. So our chi-square test statistic, in other words, step 2 of the 5-step hypothesis testing procedure, is chi-squared equals 1.77. The p-value, so step 3 of our procedure, p equals 0.1833. I'm going to show you really quickly how Minitab Express constructed the chi-square distribution and found this p-value. So I'll create a probability distribution plot, just like we've been doing for the past few weeks. But this time, I'm using a chi-square distribution. We have 2 columns and 2 rows, so 2 minus 1 times 2 minus 1 gives us 1 degree of freedom. And a chi-square test of independence is always going to be a right-tailed test. We have a test statistic of 1.77, giving us a p-value of 0.183382. So exactly what we found when we ran the Pearson chi-square test. Let's go back to our 5-step hypothesis testing procedure. So recall we just found step 2 chi-squared with 1 degrees of freedom equals 1.77. Step 3, p-value equals 0.1833. Moving on to step 4, p is greater than our standard alpha level of 0.05, so we fail to reject the null hypothesis. There is not evidence of a relationship between dog and cat ownership in the population. So when we fail to reject the null hypothesis, there is not evidence of a relationship. If we were to reject the null hypothesis, then there would be evidence of a relationship in the population. So that's our 5-step hypothesis testing procedure. There's a number of examples in your online notes this week that will walk through using Minitab Express to get the chi-square test statistic and the p-value. You should not be computing the test statistic by hand. Next, let's look at relative risk. So back in lesson 3, you learned how to compute risk. Now we're going to look at relative risk, also known as a risk ratio. It's essentially the ratio of the risk for group 1 to the risk of group 2. Let's look at one example here. 1% of individuals who are vaccinated will get a certain illness, while 5% of individuals who are not vaccinated will get that illness. What is the relative risk of getting the illness for individuals who are not vaccinated compared to those who are vaccinated? The first step is to find the risk in the two groups. So risk of individuals who are vaccinated is 1% or 0.01. For those who are not vaccinated, it's 5% or 0.05. We want the ratio for individuals who are not vaccinated to those who are vaccinated. So the numerator is going to be the 0.05 and the denominator will be the 0.01. To interpret this, we could say that the risk of getting the illness is 5 times greater for individuals who are not vaccinated. Now let's look at percent change in risk. We'll use the same scenario. Recall the relative risk was 5. So the percent change in risk will be 5 minus 1 times 100%, which equals 400%. To interpret this, we could say if you don't get the vaccine, your risk of getting the illness increases by 400%. It's really important that you can distinguish between relative risk and percent change in risk, as well as next we're going to see odds and odds ratios, because oftentimes these terms are misused in the media. So it's really important that when you read something in an article or you see something on television, that you can understand what the numbers actually mean. Now let's look at odds ratios. In lesson 3, you learned how to compute odds. Now we're going to compute an odds ratio, which is the ratio of the odds for group 1 to the odds for group 2. Using the same scenario, what is the odds ratio for getting the illness for individuals who are not vaccinated compared to those who are vaccinated? The first step is that we need to compute the odds. So using the risk, the odds for the group that is vaccinated are 1 over 99 or 1 to 99. For those who are not vaccinated, 1 over 19, or an odds of 1 to 19. So our odds ratio, recall we're comparing those who are not vaccinated to those who are vaccinated. So 1 over 19 divided by 1 over 99 gives us an odds ratio of 5.211. To interpret this, we would say that the odds of getting the illness are 5.211 times greater for individuals who are not vaccinated. Those are the key topics that you're going to learn about this week. As always, if you have any questions as you're working through the My Stat Lab or the lab assignments this week, please post them to the Lesson 11 discussion board.